Hey everybody, Mr. Bellis here. We're going to talk a little geometry right now about reflectional and rotational symmetry, different shapes and stuff like that. Here we go. We're going to start off with some basic things in terms of what reflection symmetry and what rotational symmetry is. So reflection symmetry, if I had a shape that looked like this, and we call that a triangle, it has reflectional symmetry if there is some place that we can put a straight line. Let's use this paper clip as an example here, through it, so that if we folded it on that, folded this left half over to the right half or the right half over to the left half, they would line up directly on top of each other. Okay, so if this one looked like this and like this and like this and like this, and we had an isosceles triangle, then this line would be called a line of reflectional symmetry. Is that okay? Now, if we had like maybe a capital H looking something like this, assuming that we're trying to draw this as symmetrical as possible, this would actually have two lines of symmetry. One, if I could put it right through the center of that, and I know that looks a little off, put it right through the center of that, and then another one that would put right through here. And it turns out that anytime that you have reflectional symmetry where there's more than one line in a shape, then you also have something called rotational symmetry. And rotational symmetry means that we could take it and we could spin it 180 degrees or some other angle less than 180 degrees, and all of the points would line up directly on top of itself. Like, for instance, if this was point A and I spun this 180 degrees, it would line up right over here on top of that point. And if this was point B and we spun this 180 degrees, it would line up directly on top of this point. And likewise, the original point that was here would end up right up here. Okay, so that's your basics between reflection and rotational symmetry. Now we're going to talk a little bit about some of the different things that may or may not have it. Okay, so let's take something that looks like a rectangle. Hopefully you can see a rectangle has reflectional symmetry through the middle there, which means that you could fold it directly on top of that line and it would line up on top of itself. And a rectangle also has reflectional symmetry there, which means that this shape must also have rotational symmetry. Now, just because it has reflectional doesn't mean that it has rotational. Just because it has rotational doesn't mean that it has reflectional. We want to take a look at each case individually. However, if a shape does have more than one line of reflectional symmetry, then it must have rotational symmetry. Let's take this for an instance. This is a pentagon. And you can see pretty easily, I believe, on this pentagon that there is a line of reflection symmetry that goes straight down through there, that we could fold this half onto this half, and it would line up perfectly. However, if I spun this point right here, 180 degrees down to here, you can see there's no points down on this bottom end that stick out like that top do. Okay, so again, we know that we could take any shape, even like this calculator, and spin it 360 degrees and it would line up directly the way it was. But that's not by definition what we're talking about. Rotational symmetry has to be 180 degrees or less. So you're like, well, less, what are some possibilities that are less than 180 degrees that still might work? That's a great question. Let's take this shape, try and do this correctly. This is a triangle where all three sides are the same and all three angles are the same. And if I spun this, I'd have to kind of look in here. Spun this right around this point, then to get from here, from A to directly on top of B, and from B directly on top of C, I'd be spinning it that much. Now, the question is, how much is that? Well, it's pretty easy if you think about it this way. That's one turn to get from A to B, 2 turns to get from B to C, and 3 turns to get all the way back around. So I'd simply do what it is all the way around and divide it by how many turns we had. So this would have 120-degree rotational symmetry. Does that make sense? Now how about something with something a little smaller than that? How about this one right here? This is a attempt. I know we haven't gotten into tons of detail about all of our shapes yet. This is what this unit's going to be a little bit about. But this is a square. And you can see that the square has 1, 2, 3, 4 rotations to get it all the way around. So 360 divided by 4 equals 90-degree rotational symmetry. Make sense? Now we could also look at some of its reflectional lines. So where does this have a line of symmetry? And we have to be very careful on some of these things. But look, we could split it there, and we could split it there. We're like, yes, it has 2. But wait, it's a square. It also has one right there and one right there. And again, each shape may be different, completely different. So let's take this one as an example. Kind of an S, right, or a block style 5. So if I was to do this, I could rotate this 180 degrees, and this point right here, we'll call that A, would end up directly on B, and B would line up directly on A if I rotated it around that point. And that's called its center of rotation, wherever the point is that we were able to spin this thing on, for all the points to line up directly on top of themselves. However, if I was to bring out my reflection line and I put this just like this, you can see that these points over here don't reflect over to here. There's nothing in that spot, right? And these points over here don't reflect anything over here. So that's not a line of symmetry. If I put it just like this right here, right, all of these points would line up directly on top of these points, but again, this point doesn't line on top of there. So this has 180-degree rotational symmetry, but no reflectional symmetry. Okay, so hopefully this was at least a good basis for you. Some of the things you might do is just take a look around your house right now and see if there's anything that has reflectional or rotational symmetry. Kind of like us as humans, for the most part, have reflectional symmetry, but not rotational symmetry. There's not very many people that have their have another part of their body sticking out like this, right? Where that'd be a little weird, wouldn't it? Okay, you guys take care. It's hopefully a quick review on reflectional and rotational symmetry.